This video will cover the T.1 A notes, which is our intro to trig. Trigonometry has to do with triangles. You did some back in geometry when you did sine, cosine, tangent, that kind of stuff. So we're going to do that and lots more in trig this semester. Alright, what we have here is a large list of vocabulary that we're just going to go through as our intro to trig. Some of these terms you have already seen. You saw them in geometry, maybe even in pre-algebra and middle school math. So some of these you've seen, and then some of them are new. Alright, so I'm just going to talk through some of these terms. If you need to pause at any time so that you can write down a definition, I recommend you doing that. So some terms you probably have already seen, ray and angle. So remember, ray is just, it has an endpoint and then it goes forever in one direction. And then if I connect two rays, now I have formed an angle. Alright, for our purposes in this class, we're going to be looking at angles in what we call standard position. So what that means is on the coordinate plane, the angle has an initial side and a terminal side. And when it's in standard position, alright, the initial side is going to be on the x-axis in the positive direction. So all of our angles that we're going to look at in this class are going to have a ray that starts at 0, 0, starts at the origin, and goes along the x-axis in the positive direction. That's the initial side. And then the terminal side can be anywhere, right? It doesn't just have to be this angle. I could draw an angle here. I could draw an angle there. Wherever the other ray is that determines the size of the angle, that's going to be our terminal side. And that is an angle in what we call standard position. And then, of course, you should know the origin is 0, 0. The x-axis is the horizontal one, and the y-axis is vertical. Alright, some more terms that you should already know. Quadrant. Remember, we have 4 quadrants. Start top right, 1, 2, 3, 4, goes counterclockwise. Alright, a positive angle. So what you're going to see is we're going to have angles drawn, and they're going to have the initial side on the x-axis and then a terminal side. And what you'll see is some kind of arrow or mark indicating the direction. So a positive angle goes counterclockwise. So if I start from my initial side and I go up, that would be a positive angle. Alright, and then I'm going to draw another one. If I start from my initial side and go clockwise and go down, then this is a negative angle. So when we write the angle measure, this would be like negative 100 degrees. Okay, and then the blue one would be positive 100 degrees. Alright. So if I go from my initial side and go up or counterclockwise, that's positive. If I go down or clockwise, that's a negative angle. A quadrantal angle is one that has the terminal side, alright, on an axis. So like a 90-degree angle or a 270-degree angle, alright, that would be a quadrantal angle, one that is on the axis, alright, or a 180 if we drew a straight line. Alright, up until now in all your math classes you have measured angles in degrees. So what we're going to do is kind of measure or label the quadrant. So again, if my initial side is here, alright, this would be 0 degrees. Alright, if I went all the way around, a circle is 360 degrees. Alright, and then straight up, this would be a 90-degree angle, 180, and 270. Again, nothing new or earth-shattering there. So then what you will be asked to do is find the measure of an angle. Alright, so here's an example. The blue lines are the angle. The red arrow gives me direction and how many times. Alright, and then we have this piece of information here. So when I do this, I'm going to count full circles first. So if I start here, that's one full circle, so that's 360 degrees. There's another full circle, that's another 360 degrees, alright? And if we look, the direction is clockwise or down, so it's negative. So I have negative 360, and then another negative 360, alright? Then I have another half circle, so that gives me negative 180, alright? And then this green thing tells me that this piece that is left is another 80 degrees. Alright, if I add all of those up, then this angle has a measure of negative 980 degrees. Okay, so what I want you to do is you have this classwork examples worksheet. I want you to go ahead and pause and do problems 2 and 3. Okay, then we're going to skip down to example 7. All right, this time you are asked to draw an angle that has a measurement of negative 420 degrees. So, again, I know that the positive x-axis is going to be my initial side. All right, and then I have to go negative, so I'm going to go down 360. All right, if I go after a full circle, I still have another 60 degrees to go to get to 420, okay, because that's 360. I need another 60, so I know 60 degrees would be somewhere in there. As long as you have it in the right quadrant and, you know, close enough to where it's supposed to be, that's good. So this angle then would have a measure of negative 420 degrees, because there's 360 and then another 60. All right, so why don't you pause here and try number 8. Then we're also going to look at a second way to measure angles, and we're going to use another unit called radians. Think of radians and degrees like you would like feet and meters. They're just two different units, two different ways to measure the same thing. So just a little background, a radian came about because if you remember from geometry, you can measure the arc of an angle on a circle. So a radian is just where the arc, it has the same length as the radius. That's defined as 1 radian. All right. When we get to radians, when we do that, we measure it all the way around the circle, we end up with 2 pi radians in a circle. So this is 0 degrees or 0 radians. It's also 2 pi radians. All right, so 360 degrees is the same thing as 2 pi radians. All right, so if a full circle is 2 pi, then a half circle has to be 1 pi or just pi. So pi radians is half a circle. That would make 90 degrees halfway between 0 and 1, so it would be pi over 2. Alright, and then 270 degrees would be 3 pi over 2 radians. Okay, so these are values that you need to memorize. The quadrantal angles in radians would be 0, pi over 2, pi, 3 pi over 2, and then a full circle is 2 pi radians. So now we're going to go back and do some of those examples that we skipped because they're measured in radians. So here is example 4 where we have to measure this angle in radians. So again, I'm going to go full circles at a time. So here's one full circle and it went up or clockwise in a positive direction. So that's 2 pi. Alright, then I can go a half circle and then another quarter circle. So remember from here to there would be 3 pi over 2 radians. Alright, and then I need to figure out what this missing piece is. And they tell me that the other one is pi over 4. So if this piece is pi over 4, I have to figure out what this piece would have to be. Let me get a different color here. So this whole thing would be 90 degrees, and we know that's equivalent to pi over 2 radians. So if this piece is pi over 4, then the missing piece that I'm trying to find would be pi over 2 minus pi over 4. Alright, which if I do that, I end up with pi over 4. So I got to add this missing piece, which is pi over 4. When I add those all together, I get 15 pi over 4. Okay, and we're always going to write answers in radians in fractions, never in decimals. Okay, so why don't you pause here and try these two examples, 5 and 6. Alright, here we have to draw angles given the degree or the angle measurement in radians. Alright, so negative 7 pi over 6. I'm going to show you two different ways, and it's kind of up to you how you want to think about this and which way makes more sense to you. First way is I'm going to change this into the fraction part, the 7 over 6, into a decimal. So if I did 7 divided by 6, that would give me 1.16, and then the 6 part is repeating. So it's negative 1.16, but what you have to remember is a full circle in radians is 2. Alright, a full circle is 2 pi, so 1.16 would be a little bit more than half a circle. Alright, because if a full circle is 2, then half circle would be 1. So I'm going to go in the negative direction. That would be 1, so 1.16 would be just a little bit more. Alright, so that would give me negative 7 pi over 6 radians. The second way to do this is, remember, we have labeled the quadrant of angles. So if I'm going in the negative direction, this is negative pi over 2. This is negative pi. This is negative 3 pi over 2. Alright, and then this would be negative 2 pi. A second way to do this is to make all your quadrantal angles have the same denominator as what you're given in the problem. So I'm given negative 7 pi over 6, so I would make all my quadrantal angles be over 6. So to get this over 6, I would have to multiply by 3. So that would give me 3 pi over 6. This would be 6 pi over 6. This one would be negative 9 pi over 6. Alright, and then 2 pi would be 12 pi over 6. So now that they all have the same denominator, negative 7 pi over 6 would be in between 6 and 9. So I would go to the same place. So in between 6 and 9, probably closer to the 6 because it's just 7 is one more. Alright, would give me that same angle. So you can either turn it into a decimal, but then what you have to remember is 2 is a full circle. Alright, not 1. 2 is a full circle. Or you can change your denominators so that they're the same as what you're given, and then just put the fraction in between where it belongs. Alright, some more terms that you should remember from geometry. An acute angle. Okay, remember, is anything less than 90, so that would be an acute angle. A right angle is, of course, a 90-degree angle. Alright, an obtuse angle would be anything more than 90, and then a straight angle is a straight line or 180 degrees. Alright, so that should just be a review. Okay, the next term is coterminal angles. Okay, so I have here a 100-degree angle, and when we say an angle is coterminal, what we mean is it has a different measure. Okay, so a different measure, but the same terminal side. Alright, so the angle will end up at the same place, but it will have a different measurement. Alright, so how does that work? Well, this is a 100-degree angle, right? Let me put in my direction arrow. Alright, so it's a 100-degree angle. I could also, alright, go a full circle around and then back to this same place. Now that gives me a 460-degree angle. Alright, but it has the same initial side, the same terminal side, just a different measurement. Okay? I could also go in the opposite direction. So instead of going clockwise or counterclockwise for a positive angle, I could go clockwise for a negative angle. So if I go this direction, then that angle would be a negative 260-degree angle. Okay? All three of those angles are coterminal because they end at the same place, but they have a different measurement. Okay? I don't know if you'll notice this pattern, but the way that we come up with coterminal angles is to add or subtract a full circle, 360 degrees. So if I took 100 and added 360, that's how I get that 460. If I take 100 and subtract 360, that's how I get the negative 260-degree angle. So for a coterminal angle, you're going to add or subtract a full circle. Alright, so here we have some examples. So to get a coterminal angle in degrees, I would just add and subtract a full circle. Alright, so 105 plus 360 would give me 465. That would be a coterminal angle. And then 105 minus 360 would give me negative 255 degrees. These are coterminal angles with the 105. Okay. In radians, it's going to be the same thing. We're going to add and subtract a full circle, but a full circle is no longer 360. If it's in radians, it is 2 pi. So I'm going to add 2 pi radians and subtract 2 pi radians. Okay, so negative 7 pi over 6 plus 2 pi would give me 5 pi over 6 radians as a coterminal angle, and then minus 2 pi would give me negative 19 pi over 6 as a coterminal angle. So why don't you go ahead and pause here and finish up these examples up to number 16. Alright, then our last two terms we have our reference angles and reference triangles. Alright, here I have a 120 degree angle. To form a reference triangle, I'm always going to go from the terminal side and I'm going to go straight down to the x-axis. Okay, always straight down to the x-axis. This gives me a reference triangle, and the angle that is formed at the origin is the reference angle. Alright, so that's my reference angle right there. Alright, so for this angle, if this is 120 degrees, then this reference angle would have to be 60 degrees. Alright, reference angles and reference triangles are going to be useful to us later when we're trying to figure out the value of trig functions. Okay, what you need to know is the line is always going to be drawn straight to the x-axis. So if my angle was over here, then my line would go straight to the x-axis. If my angle was in the first quadrant or the fourth quadrant, the line would go straight down to the x-axis, straight up to the x-axis. So to help you remember, it kind of forms a bow tie shape. Okay, so your reference triangle and reference angle have to be a part of this bow tie. So it's always drawn straight to the x-axis, never over to the y-axis. And then when you're calculating reference angles, alright, it depends on what quadrant your angle is in. So if your angle is in the first quadrant, okay, then the reference angle is equal to the angle. Alright, if I have an angle in the first quadrant, then I would draw my reference triangle to the x-axis and the reference angle would be the angle. In the second quadrant, it is 180 minus the angle. Alright, because it's the difference between a straight line and wherever your angle is. In the third quadrant, it's going to be the angle minus 180. And in the fourth quadrant, it's going to be 360 minus the angle. Now, this little chart here works for positive angles, alright, that are less than 360 degrees. Alright, because here's the thing about a reference angle. A reference angle has to be always positive and always less than 90 degrees. Alright, so if you get a reference angle of negative 270, you've done something wrong in your calculations. Okay, so this chart works for positive angles that are less than 360 degrees. Alright, for radians, it's going to be the same. We're just going to change out these values. So 180 degrees would be pi radians, so pi minus the angle, alright, or the angle minus pi. And then here it would be 2 pi minus the angle. Okay, so that's how it changes for radians. To make this work for negative angles, alright, negative angles less than 360 degrees, what you're going to have to do is switch the top and the bottom of the chart. Okay, so this goes to quadrant 4, this goes to quadrant 1, this goes to quadrant 3, this goes to quadrant 2. We're switching the top and the bottom of the chart. To make it work for angles that are greater than 360 or greater than 2 pi radians, greater than a full circle, we're just going to subtract a circle until we get to a number that's less than 360. And we'll do some examples. I'll show you what I mean. But that would give you a coterminal angle, so that it would have the same reference angle and the same reference triangle. Okay, so here we have some examples. So this is negative 635. So already I know that I'm going to have to switch the quadrants. So this one becomes 360 minus the angle. This is just the angle. This is 180 minus the angle. And this is the angle minus 180. Okay, and it's already bigger than a circle. So what I need is for this number to be less than 360. So I'm going to take 360 degrees away from this number. So if I did 635 minus 360, alright, that gives me 275 degrees. When you're dealing with negative angles, once you switch the places for the rules in the chart, you can kind of ignore the negative sign. It's not really relevant to your calculations anymore. It just means that we need to switch the places. And then this angle is in quadrant 1. And so quadrant 1 for a negative angle means here is my rule, 360 minus the angle. And I'm going to use this number that I got that gives me something smaller than a circle. So 360 minus 275 gives me 85. So that is my reference angle. 85 degrees is the reference angle for this angle. Alright, remember, so if I drew it straight down to the x-axis, that angle right there is 85 degrees. And that is my reference angle. I'll do one more example that's in radians, and then you're going to be on your own for finishing those. Sometimes the angle will not be drawn for you. They'll just give you the measurement. If that's the case, you need to draw it first before you do any calculation. So I'm going to draw this angle, 15 pi over 4. Alright, and it's going to be a positive angle, so I'm going to go this direction. Alright, that is what 15 pi over 4 looks like. Alright, so since it's a positive angle, I can use the rules just as they are. Alright, and this is going to be pi over 2. I'm going to use the radian rules, alright, since the angle is given to me in radians. Alright, this angle is in quadrant 4, so this is my rule, 2 pi minus theta, but the angle is more than a full circle, so before I can do anything else, I need to subtract a full circle. So 15 pi over 4 minus 2 pi would give me 7 pi over 4. Alright. Okay, 7 pi over 4 is less than a circle, so I can use this number, and it's 2 pi minus theta, so 2 pi minus 7 pi over 4 gives me pi over 4. So my reference angle is pi over 4. Alright, so if it's not given, you need to draw it first. Okay, and then use the chart, subtract a full circle if you have to first. So you go ahead and try the rest of those examples, and then you have homework B to complete.